Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, we're taking a look at carbon fiber this week.
I can't believe we haven't done this one before, considering it's the material of the future.
Future. That was good. Did you know carbon fiber is 5 times stronger than steel, but half the weight?
Oh, it got to be.
It might even be less than that.
It got to be way less than half. You just made that up right now, didn't you?
No, I saw that it was half the weight, but I think it depends on how thick it is.
Yeah.
I'm not talking just the fibers. I'm thinking like the whole material.
Gotcha.
Carbon fibers have a whole bunch of advantages. Did you know this? High stiffness, high tensile strength, low weight, high chemical resistance, high temperature tolerance, and low thermal expansion, which I think is a big one.
Wow.
So these properties have made carbon fiber very popular in a whole bunch of places, leading the way, aerospace.
Obviously, they lead the space with everything.
That's true. Civil engineering, which I thought was interesting because they're not good at anything but pouring concrete. Military uses, which makes sense. Motocross, which also makes sense, or racing as well. And then a whole bunch of other like competitive sports. And I'll get into some of those things later on. But that all makes sense. Anything that you want strong and lightweight, this is the direction it is headed.
Yeah. And something that
I thought you were just going to leave it at, yeah.
No. And something that would require like a relatively complex shape just because of the manufacturing process to make things. It's easy to work with in some cases. It's super repeatable to make the same thing over and over again because you're using molds.
Moldy.
Yeah.
It's moldy.
But before we talk about carbon fiber, I think we got to give a little bit of credit to
credit where credit is due.
Yeah, a little bit of history. The folks that basically invented it, not for what you would think, and I had no clue about this either.
Yeah, well, I don't want to say that, but go ahead.
So back in 1860, a cat by the name of Joseph Swan produced...
Not Joe Swanson,
not
like Family Guy.
No.
Joseph Swan.
Joseph Swan produced the first carbon fibers.
What for?
This was for light bulbs.
So we did an episode all about light bulbs.
How did we not?
Did we cover it then?
I don't remember covering carbon fiber during the light bulb episode. For use in light bulbs, and then in 1879, Thomas Edison baked cotton threads, bamboo. So if you imagine a super thin piece of cotton thread or a super thin piece of bamboo, you basically carbonize them, and I'll talk about carbonization here in a minute. And basically that filament then is going to illuminate once it's been carbonized.
You know, he probably stole that from someone.
I guarantee
he didn't invent
he did.
anything. Good for nothing.
But basically, for the first 10 years of incandescent light bulbs until tungsten replaced it, they were carbonized bamboo or cotton threads.
They did come up with a carbon wire as well, old Lewis Latimer. But yeah, isn't that crazy? But that's so. What's carbonization?
So carbonization is when you convert organic matter into all carbon. And basically, it's this chemical process. It's a mechanical and chemical process depending on what you're working with. But what you do is you take that piece of cotton thread or bamboo and you heat it up to a certain temperature. And what happens is the molecular structure changes. Then you heat it up again in the absence of oxygen so it won't catch fire.
Well, don't go into too much about how it's made, but go ahead.
And when you do that, it basically gets rid of everything except for the carbon, and you end up with this super... And whenever it does it, it tends to... The carbon atoms tend to line up in the direction of the threads, so it's just this super strong piece of material. So that's carbonization.
Interesting.
Basically,
give or take. So more importantly, what was the process called that Han Solo went through when he got like turned into that wall? When he was like,
I think it was he was frozen in carbonite.
That carbonite. He was frozen in carbonite. Okay.
And that was more of a freezing
process,
process, which I don't know why they would have called that.
Okay. So moving on. Did you see that the high potential strength of the carbon fiber was realized in 1963?
It took a while.
Yeah. It was. So this process was developed by W. Watt, L.N. Phillips, and W. Johnson at the Royal Aircraft Establishment in Farnborough, Hampshire, in the UK, so in England. We've been to Farnborough, or at least I have. Have you?
I was there, yes.
So we have an office there. It's just a great town. All you people who live in Farnborough, good for you for staying there. But they have the second largest air show in the world, next to Paris, I believe.
Do you know why? Because you got a good old Rolls-Royce there.
Well, that's what I was getting at,
I know.
too. You're right. So they have Rolls-Royce and things like that, but 3 companies were really working with this stuff. Rolls-Royce was making the carbon fibers, Morganite, and Cordolas.
Nailed it. Don't question yourself. You nailed it.
Don't question myself. But yeah, so it does make sense now why Farnborough does have this huge air show. And I guess it's just tradition now that keeps people coming back to this thing, because that place is the worst. Just the worst. I asked my taxi driver, what do people do at night in Farnborough? And he says, go other places.
They leave.
Yeah, they leave. So that was funny. Fun fact. You ready for it? Are you ready?
Yes.
Okay.
I can't wait. I love your fun facts.
Thank you. In 2012, estimated global demand for carbon fiber was 1.7 billion with a B dollars, with estimated annual growth of 10 to 12%. Endlessly, like going through the years still. So every year it's going up another 10 to 12%. And the strongest demand, of course, is coming from the aerospace industry, wind energy, which I'll get into later, and the automotive industry.
I think that makes sense.
That growth though, 10 to 12%. Think if your money was growing like that.
Think if you had a company that like sold carbon fiber.
I would like that.
That'd be good.
Yeah. All right. Do you have any more history you wanted to cover?
No history. I have some how it's made. We can hold that.
I have a lot of how it's made.
Why don't you start with how it's made?
All right. So it all starts, Luke, with plastic filaments made up of thousands of fibers, thinner than a human hair. I didn't pull one out. I tried and I failed. Ouch. They're about 5 to 10 micrometers to be exact, which that's about 1.5 feet?
Something like
give
that,
or take.
easily.
So super small. So these fibers are chemically altered, and this is kind of like what you were talking about. So these are chemically altered to make a perfect chain of carbon atoms. How? I don't know.
They bake it.
No, well, we're getting there.
Okay.
That's a different step.
But that's what happens.
Okay. So dozens of these fibers are lined up, and it sends them through an oxidation oven at about 400 degrees Fahrenheit, so not C, because nobody knows what that is. So this helps the fibers to pick up oxygen atoms.
Mm-hmm.
This then rearranges the atomic structure of the fiber. That's the rearranging sound. And it helps them become more heat resistant, because that's pretty important. Fun fact, the fibers start out almost white, but at the end, they end up black at the end of this process, and that's kind of that color that we're used to when we see fiber.
They actually look like super thin fishing wire, or you know what it looks like? If you cut Barbie's hair off.
I would never do that.
The Barbie doll's hair, like I used to do all the time with my sister's dolls, I would cut the hair off. It looks basically like Barbie doll's hair. And it has the same, it's just like it. It's obviously a different material. I think the material's called pan. The filament is specifically... it has a super high carbon concentration once it's used. Apparently, they can use all kinds of different materials, but PAN in particular, PAN stands for something. Polyacrylic nitrolite, also known as polyvinyl cyanide or Kreslin 61.
Wow, how did you know all that?
Google.
That was impressive. Before you go any further, back in the day, I got in trouble with one of my friends because of things we did with his sister's Barbie dolls.
Oh.
And it was not cutting off their hair.
Let's keep this PG today.
Okay, keeping this PG. So after the atomic structure is all taken care of, the fibers are sent into a furnace and heated, like you said, in an oxygen-free gas mixture. So this gets rid of all the non-carbon atoms.
Pushes everything off.
Yep. And it bonds the carbon atoms into a tight crystal structure. So, and like you said, it's always like running parallel to that fiber. So this gives it its strength. And the fibers are then sent through electrified water that etches the surface of the fibers so that they can then absorb resin more readily.
One of the ways I heard them describe it was like, imagine, before it was carbonized, the carbonization process, these two heating stages. Imagine if things were interwoven with your fingers, just where they're not locked, they're just touching each other. So it's really easy to pull away. But whenever you carbonize, imagine locking your hands alternately and trying to pull them apart, like with your fingers hooked. It's a lot easier.
It can't be done.
It cannot. Well, not my hands, because they're so strong.
Right.
But basically, you're creating almost this lock between the molecules rather than just kind of like a sliding joint. So
there we go. So after your fiber fingers are locked together,
yes,
they're then rolled onto a spool where they're either used as carbon fiber fabric or molded into a product when they're mixed with resin. And then I guess, I don't know if you have any more detail after that, but I kind of stopped at they're on a spool and then get them slapped where you want them to go.
Well, even the interesting thing about the spools, if you ever buy cheese, they put paper.
I do buy cheese.
They put paper in between the slices of cheese. So what they have to do is the top paper has a release material, and then the carbon fiber goes on top because you need to peel the paper off of it whenever you use it, and then a top piece of paper comes down that also has release material, and then they impregnate it.
Right, so that's with the pre-preg, right?
Yeah, the pre-preg. So what they do is they put this resin in there that basically keeps it pliable, and you have to keep this stuff frozen, which I didn't know you had to keep it frozen.
I didn't see that. That's weird.
And what happens is, if you imagine, it's basically a sandwich. So you got paper, release material, carbon fiber weave with pre-preg in it, which is a resin, and then release material on a piece of paper. So otherwise you couldn't work with this stuff. It would just all stick together, and like imagine like an old piece of tape.
You totally killed my next section. You just devoured the whole thing. Like a sandwich. Like a resin carbon fiber sandwich.
I didn't mean to do that.
No, that's okay. You did a good job. Yeah, it's exactly what you said. It's like a sandwich. You need that thing. I read actually that it's like a fruit roll-up.
Yeah.
Remember those?
Yep, I did.
You had that weird waxy paper?
I watched a video where they said
did you?
Not that I ever watch videos to do research.
That's unlikely, yes. Okay, so before we move on to other things, carbon fiber, let's take a break for a word from our sponsor.
I have to assume it's one of like the 7 major manufacturers of carbon fiber, because apparently that's all there really is.
Are there 7?
It's some number. It's unusually low.
They did not decide to sponsor us this episode, which was hurtful, but we do have some shout-outs, which makes it feel better. Miguel O. wrote in to us. I'm going to read you his whole email.
Okay.
Hello. My name is Miguel. I'm going to major in mechanical engineering and love your podcast. That's all. Goodbye. So thank you, Miguel.
I love Miguel. He's short, he's sweet, to the point.
That's right.
He's going to get some stickers.
Well, if he sends his address back.
I
have to reply still.
He kind of forgot to do that.
It's funny how many people have said, hey, I want some stickers. Don't give me an address, and then never write back with it. It hurts. Eric T. also wrote in, headed off to Kansas State University to study chemical engineering.
Go Wildcats.
I had purple cats. Is that what they are, the Wildcats?
I have no idea.
They're a cat of some sort.
Okay.
I don't remember what they are, though, but they're purple, I believe.
A domestic house cat.
Go purple domestic house cat. So, Eric, thank you for writing in. If any of you want to be like Miguel or Eric, which are awesome people,
clearly,
email us at unprofessionalengineering@gmail.com. What else could they do?
They can subscribe, because subscribing and liking is the currency of podcasts. I used that a while ago. I'm bringing it back in the rotation.
Marketing to its
Make sure you give us a thumbs up. Make sure you share. Make sure you follow us on all of it. We got socials coming out the wazoo.
Goodness.
We're on Twitter. We're on Facebook. We're on everywhere you could imagine.
We're on Instagram. We never post there.
Yeah.
But
who's on
follow
Instagram?
Us. Yeah, nobody. None
Millennials.
Of the cool kids. They're the worst. I like people that are too young to be millennials or too old to be millennials.
Yes.
But those millennials like me, dislike.
You are a millennial, aren't
Technically, I'm the first year, I believe, of millennial.
I knew
doesn't feel good.
I knew I disliked you for a specific reason.
And that's it.
That's it.
Yeah. Well, anyways, like he said, subscribe, leave us a review, write into unprofessionalengineering@gmail.com to request your stickers. And that's about it. That's all the chores we have for you this week.
Let's get back to lightweightness.
Oh, my goodness. Tell me about lightweightness, Luke.
So, couple interesting things. Fun fact.
Oh, I love fun facts.
The next generation of carbon fiber.
Is that Star Trek?
Star Trek: The Next Generation?
Isn't that a thing?
It is.
Okay.
So, fun fact. So, the stuff they're working on now, so like today,
right
for carbon fiber, and if they implement this in passenger vehicles, and you can see why they're doing this, it could actually reduce the weight of cars by up to 50% and fuel efficiency by 35% and increase safety. and hold on.
I'm holding.
Save you $5,000 in fuel over the life of a car, just in today's gasoline prices. So not only is your car going to be lighter, it's going to be more fuel efficient, it's going to be safer, and you're going to put less gas into your car.
Is my car going to be more expensive up front?
I think the hope is eventually they'll come up with a process, because unfortunately this stuff is not easy to make.
Well, that's what I'm thinking. It's probably going to cost me $20,000 more to buy this car that saves me $5,000 in gas.
Yeah, but okay, so
carbon footprint.
I'm sure that they're going to come up with some way to manufacture this stuff, because think about it, you don't need aircraft quality carbon fiber in a car.
Probably.
Right?
I don't know. I don't know the difference.
Because there's grades of carbon fiber, and like all the stuff that doesn't meet the spec for like aircrafts and
that goes into
aviation, that goes into like bikes and hockey sticks and stuff like that.
Yeah,
so
that makes sense.
So I think it could go into a car and still be relatively safe.
Okay. I'm okay with that.
Yeah. So fun fact.
Thanks. That was a great fun fact. What else did you have for me for lightweight? Was that it?
Yeah, that's kind of all I had.
So really what I had next in line was different uses for carbon fiber.
There's tons.
That was my whole section, because there's tons of uses.
I keep stealing your thunder.
That was it. Okay, well, I guess we're done for today.
No.
Okay. Do you want to get into anything else before I get into the uses?
Get into the uses.
Okay. Aerospace. We talked about this. Number one use, right? Fun fact. 30% of all carbon fiber is used in the aerospace industry. That's a lot. That's a lot. Luke.
Did you see the fuel tank?
I did not.
This was maybe 3 years ago, 2 years ago. So Elon Musk built
the Muskers.
The Muskers, friend of the show.
Mm-hmm.
He built a fuel tank for one of his rocket launches, completely out of carbon fiber, and it was so big this thing had to be cut in half to be able to fit into an autoclave to do the heating process, to cure the resin in the carbon fiber material. And it was, I think it was one of the largest carbon fiber structures like ever created. And the problem is they gotta test this thing, so they basically blow it up to make sure that it can hold the fuel and do everything it's supposed to do. It was ridiculously big.
Doesn't sound cheap.
No, it was. I'm sure it would. But Elon Musk, he got the monies.
He does. That's one thing I know about him because of his sponsorship of the show, is that he's got the monies.
He'll sponsor us one of these days.
One of these days, Elon. So anyways, the high modulus of carbon fiber makes it super suitable for structures to replace alloys like aluminum and titanium. Titanium's heavy and expensive, right? The weight-saving carbon fiber provides the primary reason it has been adopted in the aerospace, and then that high modulus as well. Other uses: sports.
Everywhere.
All the sports. Tennis rackets, golf clubs, if you're like me.
Antonio Brown's new helmet.
Antonio Brown's new helmet. Antonio Brown's new feet that aren't frostbitten anymore.
That's an inside joke. You got to be a Steeler fan or a Raiders fan to really care.
Softball bats. Hockey sticks, like you mentioned. Archery arrows and bows are also made out of carbon fiber and carbon fiber reinforced composites. And bicycles. You're a bicycle guy, right?
Yeah.
Don't you ride the bikes
I
like
do.
A 12-year-old?
I ride the bikes for my general fitness and well-being, but yes, I do ride a bicycle.
Yeah, so this lightweight equipment without compromising strength is great, right? So it gives you a big advantage in sports.
Well, actually, a big part of, in particular, sports, the reason why they like carbon fiber is carbon fiber isn't so stiff that whenever they flex that they're going to break or snap. So if you think of like a carbon fiber bicycle, the best part about a carbon fiber bicycle, not only is this thing super light compared to like aluminum or steel, but it has just the right amount of give and stiffness whenever you're riding the bike. And because of just the nature of the material, the carbon fiber itself, it absorbs shock, it absorbs some of that vibration and road noise. So not only is it lighter, just the right flexibility, it helps with vibration and fatigue on your joints and elbows.
Sounds great.
It's amazing.
This is a miracle substance.
Like a hockey stick. If you think of a hockey stick, an old wood one might break if you flex it too much, but a carbon fiber shaft hockey stick will bend just enough because they've laid the layers in there just right so that you get that crazy slap shot.
Boom.
So the stiffness of it is also a huge advantage in sports stuff.
There we go. Okay, so I have a whole bunch more things that it's used for that I want to talk about. But before we do that, I don't want to take any longer before we get into this week's Luke's Rant.
Okay, so I was just talking about bikes, and this is my rant. I can't afford a carbon fiber bicycle. So I don't know why, because I just looked online before we started this podcast today, and you can get carbon fiber. I can get 5 yards of carbon fiber. You're going to yell at me for my speakers being on. I can get 5 yards of carbon fiber for like $400. So let's say the raw material costs $400. The mold is going to be, a certain cost, and you can reuse that over and over again. Why does a carbon fiber bicycle cost like $4,000? Why? James, I want to know why.
So how much was $400 for the material?
$400 for the materials.
The mold creation.
But the mold.
The fabrication.
You can
the assembly.
Yeah.
The people involved in that.
Okay, maybe.
Coming up with this technology, they got to recoup their money.
You're not helping me. I could maybe see why.
You know what, everyone listening? If you love the show, why don't you send Luke a carbon fiber bicycle? Do you have a particular one?
I'm looking at the Trek checkpoint. I think it's the 5 or 6. It's the carbon fiber
well,
frame.
There we go.
So maybe Trek will sponsor the show
Trek,
and give me a bike.
Trek, hook up Luke, and you could send me one. I will sell it on eBay after signing it. So thank you for that.
But yeah, so for some reason...
They're expensive.
And I get, so raw material-wise, it is expensive. The process, there's a lot of engineering that goes in, but it's insanely expensive. And I've been wanting a new bike, and my wife is just like, yeah, you're not spending $5,000 on a bicycle. Could you imagine getting one past your wife?
I don't want to say that I'm on her side on that one.
Shut up. You're the worst.
Yeah. Okay, some other uses for it. Prosthetics is a big area that at least I like to give a shout out to. We actually have a friend of the show, who actually is a friend of the show, that I think we'll be talking to in a few weeks at Accelerate in Michigan, who I believe probably has a carbon fiber prosthetic for her extreme sporting and cycling. So that's pretty cool. But a lot of those, again, all the same reasons. Strong, lightweight, blah, 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 all fall in there as well. Wind turbines is another one.
And why? If those blades are made out of solid steel...
So the majority of wind turbine blades are using fiberglass, right? But if they were made out of steel, boy, that would be even heavier, right? Fiberglass. So on large blades, they're often 150 feet plus in length. So they're giant, long blades. And they include a spare, which is a stiffening rib, so to run the length of these blades. So each blade has a stiffening rib. These components are often 100% carbon, as thick as a few inches at the root of the blade.
That's crazy.
So carbon fiber is used to provide the necessary stiffness without adding a whole bunch of weight. And why do we not want that? Because it's important to have lighter blades for the wind turbine to spin faster and be more efficient, creating more electricity then. And so actually, check out our episode all about wind turbines and windmills.
Yeah.
That we might talk about this a little bit in. I don't think we did.
But
But you'll get the whole technology behind the wind turbine. But that's pretty cool. Do you have any that you wanted to talk about? Because I have a few more.
Go ahead.
The automotive industry, but not really. Cars kind of take advantage of it, but what really does is things like Formula One and NASCAR and high-end cars that use carbon fiber.
Yeah, cars that you and I cannot afford.
Right, exactly. Cars we can't afford, nor could we control if we were driving.
Oh, my goodness.
But I saw that not only, or as much of a factor as the lightweight part is for NASCAR and F1, it's also that look that carbon fiber gives that is part of the appeal.
That weave.
Because, that weave is just kind of symbolic of high tech now.
High performance.
And high performance. And that's one of the things that those groups are going for, is that look on top of that performance.
So my 2017 Volkswagen All-Track has faux carbon fiber.
Oh, is it? It's faux carbon fiber? That's awesome.
Like, why would you put a strip of fake carbon fiber on like the side of the door? I mean, it's not there for, and it's.
Oh, that's funny.
Yeah, so.
That's really funny.
Yeah, I think a lot of companies do the faux carbon fiber on automotive interiors because it serves no purpose other than how cool it looks.
Yeah. The military, planes, of course, and missiles, which we just talked about.
Missiles made out of carbon fiber?
So if you check out our what is it, new military technology episode, you'll find that they're making missiles that fly, I think it's 5 times the speed of sound. Pew! And we don't really have materials right now that can hold up to those kind of thermal, the temperatures that result because of the air friction moving at that speed. And they're thinking that carbon fiber might play a role in fixing that. But also things like helmets and their lightweight and high strength are also used there for military equipment when people are trekking around with all that gear on. Fun fact about this material.
Shoot.
It is radiolucent or transparent to X-rays. So it's used widely in imaging equipment structures to support limbs being X-rayed or treated with radiation. That's kind of neat.
Do you own anything made out of carbon fiber?
I don't think so. I mean, I probably do, but I don't know off the top of my head. Like, my tennis rackets are old, so they're
probably fiberglass.
They're fiberglass. I don't have any. I might have a golf club. That is.
I don't have them anymore, but I did have a set. Someone gave them to me, carbon fiber shaft golf clubs, and it was a really different feel. They were crazy expensive though.
Huh. And you don't have them anymore because you don't golf?
I don't golf.
Huh. That's too bad.
Golf's for losers.
Well, I cannot back that up, but okay. Other uses, Luke. Pocket knives. Wallets for RFID protection, no. Phone cases just to look cool and be strong, watches, and even wedding rings I've seen made out of carbon fiber. If you want to be that guy, don't be that guy.
You know what? I'm trying to think. I wish I had some now that I'm thinking about it. I don't think I do.
I'm sorry. One other thing. They're actually using carbon fiber to help with ACL tears. So usually you tear your ACL, they go and harvest a ligament from somewhere else in your body. I think they probably still do that, but they're also working to use carbon fiber to help with that process.
I have a cadaver. I have a dead.
Oh, do you?
I have a dead person's tendon in my left knee.
Oh, one of my friends I always would tease because he had a dead guy bone in his ear. Yeah. He always had hearing problems, and something was wrong up there. He got a cadaver bone in his ear.
Yeah, I got a cadaver tendon in my left knee.
Oh man. I don't know if I can look at you the same now.
I know, it's weird.
Oh, that's so weird.
There is a downside to this stuff.
Tell me about it, because I saw none.
Oh, no, there's a big downside to this stuff. Probably the biggest is the production of the raw material is super expensive.
Yeah,
it's not easy. And then, like, let's say we make something out of aluminum, right?
Aluminium?
Aluminium.
Mm-hmm.
How the proper way to say it. Thank you. And you have scrap left over, right? And you have all these little pieces. What do? You just melt it down, and then you turn into another ingot of aluminum, and then you reuse it and do whatever you need to do with it. You can do that with all these other materials that we're used to using for the last 100 years, 200 years, 500
years.
The problem with carbon fiber is it is almost unusable in after it's been like the trimmings from a mold, or there's like nothing you can do with it. So the challenge is you can't recycle carbon fiber in any way, shape, or form. So as big as carbon fiber is getting, what do you do with these piles and piles and piles of carbon fiber that are left over from aircraft manufacturing and automotive and all these sporting equipment things you're talking about? There's like nothing you can do with it. So what they've done with some of it is, if you think about the way, and I did see how they can reuse this, they grind it up best they can. And if you think about how fiberglass works, so fiberglass is basically, fibers of glass that they then put a resin on to make a mold out of it, obviously. But you can do that with carbon fibers too. So you can take that kind of leftover carbon fiber, grind it up, and then almost use it just like you would fiberglass. But it's still not as strong as it normally would be, because the directional strength isn't there like you have with whenever it's like original carbon fiber in the weave. So it's difficult.
I wonder if you could. Well, maybe the melting part might be hard, but if you could grind it up and then 3D print with it, that would be cool.
Ooh!
But it might be tough to melt it with a traditional 3D printer.
I mean, it's going up to 200 or 2,000 degrees Celsius, which is what, about
I don't even know.
About
That's a lot of Fs.
a bazillion degrees F.
Jeez.
Whenever they carbonize it.
Yeah. Huh. Well, that's something. That's too bad.
I need something carbon fiber now.
I think you need one of those wallets that have it so that your information doesn't get stolen. Now that we're making the big podcast money, we need to be concerned about that sort of thing.
We do.
Okay, if you also need to be concerned about that sort of thing and you enjoyed this episode, email us at unprofessionalengineering@gmail.com. If you want some stickers, if you need some shout-outs, anything like that, write in. Hopefully you learned something this episode, and until next time.
See ya.